Hi everyone, we'll be waiting 2 to 3 minutes before starting the webinar to accommodate for the rest of the attendees who are in the middle of connecting. Welcome everyone. Thanks for joining us and thanks for being part of our community. My name is Valan Kolika and I'll be your host for today. Just a few reminders before we start with the webinar. If you have issues viewing the stream at any time during the presentation and are using the web browser version of Teams, please refresh your browser. If you're using the desktop app of Teams, please exit and rejoin. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. Closed captions in several languages are available during the live broadcast, and you can enable them by clicking on the CC button located at the lower right corner of your screen. Feel free to ask questions at any time by typing them in the live event Q&A window by clicking on the Ask Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. Now, we often get many questions on these webinars, and we will do our best to respond to all of them in real time. In the event, if the answer was not provided, or if you may have additional questions post this event, please don't hesitate to raise them on our Azure Network Security forum at aka.ms/Azure Network Security Community. If you're listening to this after the fact as a recording, that's also a great place to ask a question. We love to hear your feedback on how we can improve these webinars, and you can do that by accessing aka.ms/security webinar feedback. And would also like to invite you to join our public community by visiting aka.ms/security community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, which you can sign up at aka.ms/security-prp. You can request features, give feedback, review our product roadmaps, register for events, or join webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. In today's session, Camila Martins will guide us through the topic of Azure Network Security for SOCs. Camila is a program manager with our Azure Network Security team, and without further ado, I will turn it over to her. Camilla, the floor is yours.
Thank you very much, Velen. Hello, everybody. Thanks for being here. I'm happy to be providing this webinar to all of you today. My name is Camilla Martins. I am a program manager for Azure Network Security. And today we're going to talk about all of the network security products that my team covers for and how it relates to security operations centers, or SOCs. Let's get started. In today's webinar, we're going to do a quick overview of what the Azure Network Security products are. We're also going to cover for other Azure products that deeply integrate with our NetSec products. And then we're going to go over which type of threats we detect and protect from with these products and how to respond and report for them. Okay. The network security products that Azure portfolio provides is the Azure Distributed Denial of Service Protection, or Azure DDoS Protection. We also provide Azure Web Firewall, Web Application Firewall Protection, also called as WAF. And WAF runs on Application Gateway or Azure Frontdoor. It also runs on Azure CDN. And we also cover for Azure Firewall and Azure Firewall Manager. I'm going to go just a little deep into each one of these products so you guys can understand briefly what they do. The Azure DDoS Protection Standard product provides protection in regards to layers 3 and layers 4 DDoS attacks. And the main difference that you're going to see here in regards to this particular offering is that it goes a little above and beyond the default basic offering for DDoS protection. When you join Azure, your resources are already protected against DDoS attack from our basic plan. But the way that that protection works is in regards to protecting the Azure platform as a whole, also protecting our own data centers. So technically, by protecting ourselves as a service provider, we are inherently protecting your own resources too. But that level of protection is not tuned into your needs. So for example, if an attack is large enough that it would impact the Azure infrastructure, our thresholds would be met, and the mitigation to protect from the DDoS attack would kick in. But let's say in that way, your service would also be protected. But let's say there was an attack against your application that was small enough to not trigger the basic protection, but big enough to impact your app, then your app would no longer be protected. So to fill that gap, this service is available. That way, the thresholds will be adjusted specifically to your application needs. And this is all done automatically. There is a tuning that is adaptive. It monitors for the traffic that your application is taking in. It is able to set a policy in which the protection will trigger truly based on as much as your application can take instead of as much as Azure can take. Along with that, we come with the offering of DDoS Rapid Response, which is support from Microsoft that you can get while you are being actively attacked in case you need any help with that. And there's also an SLA guarantee on cost protection if the attack happens to cause your systems to auto scale, and we can prove that there is a connection to failure to mitigate a DDoS attack caused your systems to auto scale and incurred costs, you have a cost protection guarantee there. Our Azure WAF is our layer 7 protection for web application attacks. And the way that this works, it protects you primarily in 3 ways. It has a set of built-in rules that are based on WASP. Those are managed rules by Microsoft, and they protect against the most common web app attacks out there, like cross-site scripting or SQL injection, etc. And you can also create custom rules. Custom rules can be built in a very, so many different ways, but you can create rules that are based to trigger from matching any type of patterns in like a header or a string query, a URI, It could be geo-filtering, it could be size restriction. It is going to allow you to create many types of use cases to prevent for things that are custom to you. And the third type of rules that we have is bot protection, which the WAF will be able to identify when the attack is being generated by bots, and we'll be able to take an action given on that. The bot protection is powered by Microsoft Threat Intel. We have a feed that auto updates and keep our databases really up to the latest updates to protect you from known bad bots. The configuration, as any of these products that we're going to talk about, can be done via the UI or in any other methods like a PowerShell or ARM in Terraform, which will enable you to create any type of DevOps or CI/CD deployments within Azure. And Azure Firewall is our offering for a cloud-native firewall, which is a network firewall, but also provides layer 7 protection. And if it filters traffic like our standard firewalls that we have in our data centers, it does east-west, meaning it will be able to filter traffic from like within Azure or something that is internal, and it's also does north-south if you want to put it on the perimeter, and filtering traffic outbound and inbound to the internet, or even to on-premises or other environments external to Azure is something that the Azure Firewall can do. The Azure Firewall also has three types of rules that can be configured on them. So you can configure this traffic based on network rules, which is a standard, source destination, a port, and an action. Or you can also create application rules, which will allow you to determine FQDNs as an access. So if you want to say, the source can connect to Microsoft.com or star.microsoft.com on port 443, it's also something that can be done. Another type of rule we have is a destination network address translation rule, so also known as DNATs. And that one will provide an inbound type of access control, in which you will assign a public IP that will be listening on the internet. But that public IP will be able to perform a translation into your internal private IPs and accepts access from a public IP and translate it into an internal resource. All logs are available. They're centralized for Azure Firewall, but as I'm bringing this up for Azure Firewall, logs are available for all of our other products too. They also become centralized, and that's one of the things we're going to focus on today, since we're focusing on SOC. Logs are essential for the day-to-day practice. Let's go over some of the network security integrations. I think some of these products, they are based on security and based on network, even though they may not be exactly part of what the network security in Azure my team covers for, but they are deeply integrated. We handle these products all the time. These are products that enable us to do our day-to-day operations, to see what's happening in our environment. And each one of them, sometimes their feature sets may overlap a little bit, but each one of them has like their strength, right? So Azure Sentinel, which is our Azure SIEM, it's a scalable cloud-native SIEM, right? So it's been helping a lot of people get to manage a SIEM, and without having the overhead of worrying about capacity and worrying about just general systems maintenance. And you can focus 100% on security. Azure Sentinel delivers security analytics and threat intelligence for your enterprise. It's going to be a single location where you're able to detect any type of threats, and you can then also enable your analysts to go threat hunting, doing investigations, deriving reports, and even triggering automated responses to certain events. Azure Monitor is I'm sorry. So Azure Security Center is a security management tool that helps you improve your security posture. It will provide you recommendations. It monitors your environment, and it's able to tell you, hey, if you configure your systems this way, you're going to be more secure. It provides you recommendations. It provides you with scoring. And it also has an threat protection. So it is able to give you alerts also in the event that it identifies something something malicious or something critical has happened with your workloads. Azure Network Watcher is a tool that allows you to monitor and view metrics in regards to Azure virtual networks. So this is where, when you are looking for NSG Flow Logs or anything that gets into deep details of your network mapping, your network patterns, this is where you would go to. It does help you identify network traffic filtering problems. So if you don't understand what's happening, why traffic is not getting from A to B, this is a location where you can go and go to and do that analysis. It helps you identify some routing problems. It helps you figure out what's happening with your inbound and outbound connections, or even capture packets from like VMs if this is something that you need to do. Oh, I think I forgot about Azure Monitor. There you go. Azure Monitor is the location where you can basically view all kinds of metrics and all kinds of logs. It acts on the telemetry for your cloud services. So you would be able to understand how your applications or your resources are performing. You could actually create alerts from these metrics or these logs that you have, in so that you are aware of what's happening with them. You can drill into using log analytics from Azure Monitor. You can just truly do extensive queries and deep dive into all of those logs and metrics and see what's happening with your workloads. It does allow you to create some visualization reports also with Azure dashboards and Azure Workbooks. Here's a quick, it's a quick diagram of how everything joins together. I know sometimes there is a lot of information here, but actually, if we go step by step, it might be a little easier. We can see that on the top center, public internet coming inbound, we're using Azure Global WAF, which would be our front door with layer 7 protection for your web app applications. Underneath that, we would have the Azure DDoS protection, protecting the public IPs that are assigned to like our Azure firewalls or our Azure regional WAF, which would be our Azure Application Gateway WAF. This means that we would be protecting this whole environment from a DDoS protection, along with the Azure Firewall being able to filter traffic based on network rules, threat intel, or application rules, and the regional WAF enhancing also the web application protection. This is on the public path side. Again, we just can connect any of and protect any of the public path types of resources using these tools, just like we would be able to protect the private path tools resources on the other end. And on the bottom, we can see that there are connections via VPNs or express routes that we can connect to external on-premises destinations. Okay, so that was an intro of our products. Let's go on with the part where we start detecting and protecting our systems and see what we can cover for. Before I get into what these tools are detecting and protecting from, I want to share with you guys something that may seem very simple, but actually could be a common misconfiguration or misconception that happens in Azure. There are two different log types. Excuse me. There are two different log types that come about in our environment. One of them is called activity logs, and the other one is called diagnostic logs. Activity logs are enabled by default. This is the logs that the platform provides you to understand at an administrative level what is happening to your resources. So it is for the platform, and it has to do with the management plane. It has to do with, hey, what's happening, who is managing and who is doing what to my resources. So if you create a new Azure firewall, if you turn off a new Azure firewall, right? If you create a WAF policy and you attach it to an application gateway, those are the things that you will see in your activity logs. You're going to see what is the name of the administrator that did that, at what time, etc. In the log analytics table, when we search and we do a query for a log, you're going to search for Azure activity. And this is something, again, that will give you the visibility at that level. What it will not do, it will not give you information on what is actually happening, like inside of your resources, inside of your applications. What is the behavior of who is connecting to and from, who is attacking with a SQL injection. Those are not things you're going to see with activity logs. You need to enable diagnostic logs to truly get visibility on what's happening within your resources. So this is what we mean by resource level. And in the data plane, meaning what is the activity that's going in and out of your resources. When searching with the KQL query, you would use the Azure Diagnostic tables for that. So what does that mean? It means that if you have an Azure firewall and you want to say, well, I want to know what my VMA is connecting outbound to the internet. I want to know where it's going to. You will need diagnostic logs to be able to see that type of information. If you have a WAF and you have a custom rule that says, I need all access from Canada to be blocked to my application because we are not allowed to do business in Canada, and you want to be able to see any type of logs, has anybody from Canada been connecting or etc., you would need diagnostic logs to see that type of information. So even though those types of logs are different, you do have the capacity of sending them to the same destinations. And these logs can be centrally located in Azure Storage, Azure Monitor Log Analytics, and these are in the workspaces, or Azure Event Hub. And from here, if you want to, for example, use Sentinel SIEM within Azure, you can connect the workspaces to Sentinel, or if you have an external SIEM on-prem or in the cloud, but it's not something that's cloud native, you can also use the Azure Event Hubs, and ultimately the logs would end up in your centralized SIEM at a different location. So when it comes to Azure DDoS protection, let's see what we are protecting, what types of attacks we're detecting and what we're protecting from. DDoS protection is detecting specifically volumetric attacks and protocol attacks. So it's very important to understand that volumetric attacks are the ones that are exhausting your bandwidth. So they truly are, it's generating such high volumes that your network gets clogged. And that's how access is then denied to legitimate users. And protocol attacks are attacks that are going to attack intermediary systems that provide access to your applications. So if you have like a load balancer in the middle, if you have a firewall in the middle, or even the application server itself, if those resources can become exhausted somehow because of a flaw that they have and abused, then they would go down, and because they are intermediary to access your application again wouldn't be accessible anymore. So those are the types of attacks that we detect with this service. A lot of people ask about if we are detecting layer 7 or application layer attacks with DDoS and DDoS protection standard. At this time, it's not something that this service offers. So if you do have a need or requirement to protect from layer 7 application attacks, you would need to investigate other methods to do so. We do have plenty of network virtual appliance NVAs that can be deployed to Azure that would cover for this particular use case. So once we are detecting this type of attack, how do you protect from it? Like, what do you do? In theory, the DDoS protection service actually is one of the most hands-off when it comes to SOC. Okay, so as an analyst or an incident responder, you truly don't have to take any action on this one. It is consistently monitoring your traffic intake. It is setting a threshold for you. Once the threshold is exceeded, the system, the engine will simply start mitigating the traffic. It will split the traffic. So traffic is coming inbound, it's going to split it, it's going to scrub it and verify whether those packets are malicious or not. And if the packet is deemed to be bad, it's going to be dropped. If the packet is good, it's going to forward it to service. So your legitimate users won't see any type of denial in their access. And this is what happens. So from a SOC perspective, what we normally recommend on this particular service is more about awareness and reporting. And we're going to talk about how to set up an alert or how to get notified about it shortly. But in theory, it's a little more hands-off when you're trying to protect against these types of attacks. So let's cover for our web application firewall or WAF here. What types of items can we detect with WAF? WAF would be able to something that I spoke about in our opening, but it does detect managed set of rules, which we have built in. It goes into the dozens of rules. It's all OS based. It does protect from the most common vulnerabilities out there, generally top 10. And custom rules, it will detect against anything that you configure it to detect. If you have a particular use case, if you want to be able to say, well, I have a search bar in my website, and I want to say that if somebody hits the search bar more than 1,000 times per minute, block them. That would be something that you could do. And bots, it's the system is intelligent enough to understand if there's some type of bot behavior in which you can identify bad bots or known bots or unknown bots, and you can take an action to determine what you want to do with that traffic. How are you going to protect from these types of events? So when it comes to web application firewall, there is some tuning and some choices that you have when you're going to protect from these events, right? So you can decide whether you're going to allow a certain traffic to go through, if you're going to block it, if you're going to redirect, if you're simply going to log and notify. You can also create any types of workbooks that will help you visualize the amount, of traffic that is coming through the door, the amount of events that are hitting your WAF. And this would give you good visibility on what's happening with your web application. The Azure Firewall is going to be able to detect any type of traffic that is to and from malicious IPs and domains. This is something that is done with the threat protection from the firewall. The threat protection is also using Microsoft Threat Intelligence feed at this time. It does work on inbound and outbound connections, and it's able to then obviously either alert only, so you can configure it to say, hey, I want to be notified when there is a match, but the traffic is still going to be allowed, or you can configure it to alert and deny that particular traffic. When yes, so you obviously can create any types of rules based on your needs. There are ways for you to use service tags for you to create rules if you are handling traffic internal to Azure. That would help you also, obviously, that will help you control the access, but without having to worry about changes in IP addresses in services. You can also create DNet rules when you're trying to control inbound access to your applications. All of these items that you're protecting from will be generating logs, and you would be also able to derive any types of alerts from these, any types of reporting from these, in case you need to have more visibility on these. Okay. So going in to responding and reporting, one of the items that we mentioned before that is super important to enable the diagnostic settings, but we want to give a tip here on how you perform your particular searches. So when you have a specific diagnostic setting area that you can see on the right side, there will be in your configuring where the logs are going to go to, you're going to see that there are some categories listed right there. So in this picture, we are showing you the DDoS categories. Those particular categories, exactly as they read on the diagnostic settings page, is what you would search for when you're doing your KQL queries. So if you're going to search for DDoS events, and you can't quite remember what the table looks like when you're doing that particular query, you can just come here and simply copy paste. I use it all the time. Copy paste into your query, and that will bring in the results that you're looking for. Let's see. So with that said, I have the slides, but I think I'm gonna show you guys a couple of the logs over on the portal. I'll use the slides in case this gets a little slow. So let's go over the DDoS ones. And of course, it's going to be slow, right? Let's give it a try. What are the odds? It always works when I'm not doing it live. Let's go here. Was anybody going to say anything?
No, I was going to say, hey, there's good that you had a backup.
Yeah, I have the backup, but I'll keep an eye over here. Hopefully, I'll be able to show some of the other items. When we are searching for DDoS, we're going to see three types of different logs. We're going to cover for them briefly here. When the first one is called DDoS protection notifications. This log is excellent for you to be notified of when a mitigation started and a mitigation ended. So you can use a query, and you can generate an alert from this. You can be notified. There's so many things you can do when creating alerts from within Azure. You can obviously open a ticket like in ServiceNow or other. You can you can send out Teams like webhook message to be notified. You can send an email to be notified. So a variety of items can be chosen there. But this one would explain to you whether it would be able to notify your team that a mitigation has started. So you would have that awareness that your systems are under attack right now, and that the Azure platform is there to mitigate that attack. The mitigation reports are one of the most detailed ones. So this is able to show you every 5 minutes. It provides you a log with all of the details of the activities that happened in those last 5 minutes. And when the attack ends, it will provide you a full report of called post-mitigation report, which will include all of the details that your systems went through the whole event. And it will tell you what the traffic statistics were, how many packets were dropped, and how many packets were forwarded to the service, what the countries that were attacking you were, what the ASNs that were attacking you were, etc. This is truly great to do a postmortem or to do an executive report. The mitigation flow logs are the ones that are logging every single packet that's coming through the door. And it will tell you whether that packet was dropped or whether that packet was forwarded to service. If the packet was dropped, it will give you the reason why. So like in this example, we have a couple, we were saying it was an invalid TCP or it's an invalid TCP SYN. That means that they dropped, the mitigation system just dropped it, or it will tell you packet was forwarded to service. That means that the connection came through, we deemed it to be okay, not a risk, and ultimately that that packet was sent to the service and the user gained access to the service. Super brief, because we're talking about incident responders here. If something is happening or under attack, you know, the system is pretty automated, so technically there's not a lot analysts can do while the DDoS is kicking in, DDoS protection is happening. You can always get access to Microsoft support. And this comes with the DDoS protection standard offering. You have severity A rights on this, which will get support pretty fast. And all you have to do is in your portal, you go under help and support and you create a new ticket and make sure that you select severity A and that you explain that you are under active attack. Okay. So application gateways, firewall logs. Application gateways, we'll have a couple of different types of logs, but we're talking, focusing on the WAF logs here. These are the ones that are specific to the WAF functionality within the app gateway. You can see that it's going to tell you if you what action was taken. If a request matched a rule that then was triggered, it's going to give you a log. It will give you the reason why it matched, the rule ID, and it will tell you what action was taken, if it was blocked, if it was allowed, depending on how you configured, if it was redirected or simply logged, it's going to tell you right here. One of the things that I would like you guys to notice is the very last item on the bigger picture. It's called a transaction ID. Because of the application the way the application gateway WAF works, it works. The WAF engine functions at an anomaly scoring mode. So sometimes when there is a match of a single rule, the severity of that rule may not be enough for the WAF to actually trigger and block the event. Okay, so it has to meet a 5 points in order for the WAF to actually block that event. And let's say that you want to know, well, how many events were part of, how many logs were part of that same event? If you filter by this transaction ID, it's going to show you all of the logs that were related to that same event. And that way you can see, oh, it looks like a particular request matched 3 or 4 different rules, and with the combination of those 3 or 4 rules, then the threshold that anomaly scoring exceeded 5 points, and that's why it became blocked. This is something that helps you map what ended up happening with those requests. There is so what I did here, let me come back one more. So this is my transaction ID, and I want to show you how I can link that back to a different type of log that is called the application gateway access log. So the access log is different from the firewall log because the WAF logs, because every request to your app gateway endpoint has an access log. So whether they they were 200, 400, 403, or 404. It doesn't matter. Every request will be always logged. But the WAF logs will only be there when there is a match to a WAF rule. Okay, so in that case, there was a match to a WAF rule, and I simply linked it back to the access logs. But the interesting thing to notice, while the access logs will provide you some extra information, such as the user agents, the HTTP versions that were used, etc., it also gives you the HTTP status, which I can see a firewall 03 here. So that ensures me that the WAF log that I saw previously, there were enough events that resulted in a block. So the user truly got a 403 back, unauthorized access back. Here is for the application. Oh, sorry, this is for WAF right here in Frontdoor. So the log is very similar. It's going to give you all of the details, client destination, what matched on, which rule it was, the rule ID, what action was taken, if it was block, forward, etc., block, redirect, etc. The difference between this one is that the Frontdoor WAF does not depend on anomaly scoring, and it truly is a binary match. So when it matches, the action is taken. It doesn't have a lot of, you won't be able to see if there were multiple events that added up to a score and then blocked something. It's whenever it matches just one, it's already a match, period. But it also has a similar approach in regards to connecting to the access logs. So in this case, it's just called a little different. It's the bottom line also on the bigger image. It's the tracking reference. So the tracking reference is what would link you back to the original request, just from my standard access log perspective. And you can see that I mapped it back here, same concept. It returned a 403, and I can see further details. Like I can see that, for example, they used TLS 1.2 in this particular request. I can see which POP, which POP for the front door, it was London, so I know where the access came from, etc. And going a little deeper into the Azure Firewall rules, these are what the logs are going to look like. The Azure Firewall rules, when you filter, when you do a simple query for them, you're going to notice that all of the details are within a single message, which is the message field. So this is something that makes life a little hard for analysts, because since all of the details are within a single message, it's very hard to parse, it's very hard to filter. So with that said, KQL as a querying language is super powerful. So we can actually break this down, and so that it would appear like I have on the pop-up box here. You can see that everything now has been parsed into their own fields. This would allow for analysts to obviously filter way faster and get to the point of their investigation way faster. I have a link up top where it's, if you guys, I know you can click on it, but if you just Google it and search online for Azure Monitor Logs for Azure Firewall, you're going to be able to find the queries I'm referring to. The KQL is already written for you, and you can adopt that into your SOC to be able to have a better visualization of these log types. As an application rule here, we are seeing source and destinations, and we are seeing the FQDNs, which were tried to be accessed. In this case, it was a blob storage URL on port 443, and we allowed the access. Network rules are similar concepts than what I just explained for the application rules. They are also all within the same message field. We also have an option for you to use the KQL in our site, in our docs site, and we can filter based on protocol, source, destination, and ports used, and then what action was taken. Firewall has a new feature, which is a DNS proxy feature. So we're going to be seeing a new type of log now, which is a DNS proxy rule logs. These logs are going to be able to show you what the translations were from a particular IP into their DNS name. And it will give you visibility in what the response code was, if the protocol was UDP, TCP, which kind of DNS record it is, and etc. So this is one of the examples that I had set up. I wanted to show you in my portal, but it's truly acting up here. Whenever you have any of your KQL queries within Azure Monitor, you're able to simply click on that plus new alert rule in there. There will be a few other settings within that you can create. But again, from that alert rule, there are you can connect. You can do any type of notifications that you want. That makes more sense for your team. And it does not matter like how advanced your query is. It could be a simple query. It could be a super detailed query. This can be done with any of them. The example I have here is solving for a very cool use case that we use for fine tuning our WAF. So when like before we have WAF in like prevention mode and we have it in detection mode, it's very important to understand what kinds of traffic would be blocked, right? If you turned it on to prevention mode. So using this to fine tune and tweak your rules and make sure that false positives are taken care of, I'm filtering saying I want to know anytime my WAF is blocking something. So let me know. That way I can go check for that block message and I can investigate if that is a true block, if it was a true attack, or if it's a false positive, right? And that way you can identify what's going on. You understand when there is an alert coming through the door and you don't have to look at it all the time, but you can just go investigate when it's applicable. Azure Monitor can also derive charts from the queries. Also, there is a variety of types of charts that you can do. I'm creating here a pie chart of my web firewall logs, showing the types of rules that in percentage that appeared in my environment. Something to expand on the charts, it's the Azure Workbooks. They are a bit more powerful than those charts. While they still provide a graphical representation, they are an interactive way of filtering through your events. So the workbooks can be derived from metrics. They can be derived from logs. They are extremely customizable. You can do you can create anything that is applicable to your environment that you want to have visibility from. When you select an item inside of a workbook, items will filter through. They will auto-update, helping you gain a little more visibility on what's happening in your environment. It helps with threat hunting. It helps, you know, for SOC analysts also that maybe can have those monitoring environments in their SOC that they have a visual way of when they need to take action when like a red alert pops up. This workbook, amongst others, this one is for Azure Firewall, but we have workbooks for WAF, Azure Firewall, and also DDoS protection. In our GitHub, you can go to aka.ms/aznetsec, and you can deploy from there. We have the deploy to Azure button and everything, templates ready, and you can either build one from scratch or you can take the one that we've built and it's in GitHub, and you can customize it from there. For people who are using Sentinel in their environments today, you can also take advantage of Sentinel analytics. The analytics are logic that is also based in KQL query. We do have some templates of built-in items that you can simply enable, but you can enable or you can customize them, but you can also create your fresh KQL with the logics that you need. Once you create that KQL, it's going to monitor your environment for a match. If a match happens, it's going to create an incident for you to investigate what's going on. The best thing about this, though, is that it's going to allow you to connect that incident with an automated action if you want. But before I go into that one, I want to make sure that you guys see the link on the top right. We have a blog post that truly goes into step-by-step details of how you can create an analytics rule and how you can connect it to a playbook, which would then automate a response. We have a couple very good use case examples there. A lot of KQL query samples. It's very helpful, and I highly recommend reading that article. And here is about the Sentinel playbooks. So once you have an incident and you're monitoring for a particular type of event, and let's say that there was a match, you can create a playbook to then trigger any type of automated responses that you want. So in the article that I linked over in the previous page, we are showing you to monitor for when public IPs are attacking when there is malicious activity to an application gateway public IP. And once we identify that the IP is malicious, we're going to take that source IP that is attacking us, and we're going to actually place it on our application WAF to block it. So we can take the input of something that we found via Sentinel, and we can automate the action to then input that information into our WAF into a custom rule. And it's obviously a simple use case, it's just one, but it is just to display how logic apps and how using the playbooks can help you automate some responses instead of doing it all manually. Another integration that we have, another tool that is super helpful when we're talking about network security is using Network Watcher. Network Watcher will allow you to get a visualization of your network your network topology, right? It can help you troubleshoot routing connections. It can help you monitor and also alert on any connectivity that you have. And within here, this is where you would activate your NSG Flow Logs. If you are interested in capturing NSG Flow Logs, you would go to Network Watcher to enable this. One of the things that we want to mention about NSG Flow Logs is that they have to be saved into storage right now due to their size, and you must use traffic analytics in order to review them. But from traffic analytics, you can actually you can read from traffic analytics to get the information that you need, but you can actually move them back, write them back onto the log analytics workspaces. And from log analytics workspaces, then if you're using Sentinel, for example, you would then be able to read these NSG flow logs with Sentinel via the log analytics workspaces. The use cases for NSG flow logs, generally, it's for monitoring your network. So if you are trying to identify like unknown traffic, undesirable traffic, some high bandwidth consumptions, it's something that you would search for using NSG Flow Logs. You would also often use this for forensics, right? If there is an event and you have to get really deep into the analysis of those packets in bytes to see what truly happened for forensics, that's where you would go. Some companies also need to have them for compliance reasons, even if they are in cold storage, but having them, for a year, for 2 years, just in case they probably need forensics in the future. And last but not least, we're talking about how Azure Security Center can help you improve your network security response and protection. So there will be lots of recommendations that are network related within ASC. And we, for example, it will tell you if you have management ports open to the internet and that you should close that. It will tell you if you have NSGs that are not protected. Sorry, if you have subnets that are not protected by an NSG, and with that, you would be able to identify problems that you can then fix, improve your security posture. But beyond that, it also provides security alerts. And one of the security alerts that we have integrated, built-in out of the box right now is for DDoS attacks. So if you are under attack, Azure Security Center is also going to protect you. I'm sorry, going to notify you about that event, and so you have awareness of what's going on in your environment. And with that said, this went by pretty fast. I am
Didn't it?
Yeah.
Yeah. Well, thank you so much, Camila. We're reaching here towards the end, top of the hour, and we had lots of incoming questions. That team took care of it. Thank you for that. I would like to remind the audience here that tomorrow we'll be hosting a webinar on Microsoft's Digital Defense Report. And then on Thursday, we're completing with Azure Network, that is for this calendar year, with Azure Network Security Series, going over the advanced architecture. And if you haven't registered yet, I would encourage you to do it at aka.ms/security webinars. Link is already posted here in the IM. And in case we missed to answer your questions, which I think we took care of it. However, if you have additional questions, you can visit us on our Azure Network Security Forum at aka.ms/Azure Network Security Community. So again, thank you so much for an excellent presentation, Camila, and thank you to the rest of the team who helped answer the questions. And most of all, I want to thank all of you for your continuous support in our community, and for joining the webinars like this. And we hope to see you next time. Goodbye.